So if you were in a race, it'll be like the last, like a little final stretch, almost at the last little water point, maybe 2 or 3 kilometers left to go. So thanks for sticking in there, everybody that's been here for the last 10 weeks. So next week is our last class. We'll do the last little advanced subjects on there, and then I'll also go through some tips and tricks for going and writing the certification exam. So definitely join next week. So looking at the quiz, average was 70% this week, so it's gone up. We also had like 2 more people write this week, and this week 2 people got 100%. So looking at the bottom 2 questions, they're both on 50%, so it's not really, it's okay. So at least on that like 30% or 20%. And there's a lot of questions like 75%, so I'm not going to go through them. All right, so the bottom 2 were question 7 and question 10. So looking at question 7, this one's just asking a question and checking to see if you know what the criteria query would look like. And I think sort of looking at these types of questions, and I'm pretty sure you'll get a few of them to test if you know this, is to sort of not just go and sort of read and sort of think about what the criteria query is going to look like, but sort of maybe write down the actual SQL statement you would write for this, and then convert that to a criteria query. So the question asks if to go and find out if the departments which have students that didn't do presentations or something, but then just sort of the one thing is that you're going to have that you want to do is we're going to probably do a left outer join. So you're looking for a relationship where there isn't presentations, so students that don't have presentations. So we definitely want to do a left outer join there. And then we also want to do a group by, because that's sort of whenever you have to count anything or get a number of things per something, so a number of presentations per student or students per department or employees per company, that usually means you have to do a group by. So looking at our criteria query, we definitely want to look for a left join, which we've got 3 of, and we definitely want to look for group bys. So on the left joins, that leaves us with 2 that's left there. So it's the criteria query that's second and the bottom one. And then the main thing is the one uses a where clause to go and look for presentations, and the one uses a having. And because we're doing a group by, you want to do a having, because you want to actually go and filter the results after counting them, so after in the group by. So if you did the top one, I don't actually even know if that will give you the desired results at all. I'm not sure what will happen with that, but so the correct answer is the bottom one. So one thing is we're looking for a left join because we want to see relationships where there aren't any data, and we're also doing a group by and a having because we want to see the guys that didn't have any presentations afterwards. And you can also see this one is using that metadata, generated metadata model to actually do the queries. You can see the student underscore enrollment type. Then, so I just went through that question. I think that's just my sort of way that I would approach that question, that I was sort of trying to answer it. So this next one is just one of those you need to know questions. But it's also a tricky one, and I think that's why it's in the bottom 2 questions. And it's, if you just go and inject an entity manager into a E-compliant container or into a component, that'll be a bean or a servlet or something, what type of entity manager is that's going to be? So first off, there's 2 ways you can inject these. So the one, not 2 ways you can inject this, but you can either inject the entity manager using the persistent context annotation, or you can inject the entity manager factory using the persistence unit annotation. So here we're specifically injecting a manager. So that means because we're not injecting the factory, it can't be anything other than a container managed one. Then the trick here is that it can be either transaction scoped or extended scoped entity managers, and they're not specifically saying which one it is. So because I'm not saying which one it is. It can be either one, or it can be both. So that's why this third option is the one to go for. So it's actually one of those tricky ones, and it's one of those things that if you do get this in certification exam, you just need to think through and just go for the most logical one. So that look for these types of questions where they don't give you a specific scenario. It's sort of very general, and then just say, okay, well, it can be either one. So sort of these sort of little tricky questions that Oracle love to do in the exams. And I've sometimes found that they sort of do those ones like early on in the exam, so you get to like the fifth question, and you're sweating, and your palms all sweating. You're like, I didn't study for this. What am I going to do? But I say, sort of, if you get any of those questions, if there's anything like that you're not sure of in the exam, using the 2-minute rule, go and mark it, come back to it later. So don't go and spend 5 minutes having a philosophical debate with yourself about which one's the correct answer if you're not sure about it. All right. So let's get into this week's topic. So this week's topic is around transactions unlocking. I'm not going to spend a lot of time on transactions because we've actually touched on it a few times, and then also there's a whole section on how transactions work in the JEE components in beans and so on. So if you didn't do the EJB certification that we did a few months ago, there's a whole lesson on this. So at the end of this presentation, I've got a link to that YouTube video for that lesson, so you can go and watch that. I'll go through the entire presentation on how transactions work there and do the demos and so on. So I'm not going to, so I've got a lot of the same slides in here, but I'm just quickly going to go over them. So if you want to see these in details, if you're not sure about it, go and watch that YouTube video. So the main thing about transactions, specifically, is that they are assets, atomicity, consistency, isolation, and durability. It says that you're protecting your data, making sure that whenever you are actually reading data or persisting it, that things are predictable, that you know what's going to happen. And then using EJBs, there's two types. You can either have container managed or bean managed. So container managed is one where we use our annotations, and bean managed we actually programmatically go and do it. And it's another thing that when it comes to transactions and in the JEE containers, the transaction manager uses two-phase committing. So two-phase, not like he's sneaky, or like two-phase like in two different phases. And the way that works, I'm just going to go to the next thing, is that you've got your transaction manager sitting here, and in your beans, through the JTA and through the interface, access your transaction manager. So transaction manager actually talks to the different resource managers, and these could be databases, or resource managers, any other resource managers like JMS or any Java connector architecture type connections. And the transaction manager will then go and say and ask us when the bean says, okay, go and commit this for me, or the container says, we're at the end of this method, go and commit it. Your transaction manager will then go and ask all the resource managers and say, listen, are you guys ready to commit? If all the resource managers say yeah, then it says, okay, then you can go and commit. So then they actually go and commit. And if anything goes wrong, it'll be rolled back, and this whole thing around that. But that's what is meant by two-phase committing. First it goes and asks, and then says, okay, well, go and commit now. So with the container managed transactions, those are the default type of transactions used in EJB. So if you don't specify anything, it's going to be container managed. You can change this on your class level by annotating with your transaction management annotation. It's saying that you want that as a container or a bean. And then because it's declarative, we're going to use our transaction attribute annotation. It's actually going to say what type of, or how the method or the class or the bean should handle transactions. And there you have your, what's that, 6, 7? I think it's 6, yeah, transaction attributes. And you're going to need to know this specifically. So you're going to need to know for the JPA stuff, they're going to test you more about understanding when there's a transaction and when you can join that transaction and when there's not a transaction. Because if you recall back to when you looked at the entity manager, if you're going to do the find call on your entity manager, it doesn't care that if there's a transaction or not. It doesn't matter but if you're going to do a persist call, it's going to look for an existing transaction. If there's no one, it's going to create one. So it's looking at this and combining this with your EJBs, when there's going to be a transaction, when there's not going to be a transaction, what's going to happen, they're just sort of going to have to figure out with these questions. So I said there's 6 different ones. The default one is required. So required transaction means that if a call gets made to the bean or to the method in that bean, if there isn't a transaction, one will be created. If there is a transaction already active, the bean will just start participating in that transaction. Requires new means that if there is already a transaction, it'll actually pause that transaction or suspend it and create a new transaction for that specific one. Support just means if there's a transaction, join it. If there isn't one, doesn't matter. Mandatory says it needs to have a transaction, but it can't create its own transaction. So there needs to be an existing one. Not supported just says, listen here, I don't want to partake in any transaction, so a transaction gets paused before it enters the bean. And then never just says, listen, there mustn't be a transaction. So if you actually try and call that specific method on a bean when there is a transaction, it'll freak out and say, hey, I don't want a transaction. I don't need this. And then for message-driven beans, so the message-driven beans will only be required types of questions, which you'll definitely get, and it'll give you a scenario, maybe 4 or 5 different beans that go and call each other. So it'll give you a scenario. So it'll say bean A calls bean B, and then bean B calls bean C and bean D, and then they'll give you the different types of attributes that each bean has, and you'll need to sort of say, okay, well, is a new transaction going to be created or not? Is this actually going to work or not? And you'll need to give feedback on that. And then rolling back on these, so with a rollback in a bean, so if you're not using the JPA, there might be combinations of these types of questions where one bean might be using the JPA and another bean might not, or it might be a bean that's just using the normal JTA that involves messaging as well, and then actually calling into a data managed bean that's going to use some data management and then using a different one there. So they might combine with this as well. So then you can actually go and roll back transactions. So because the container controls the transaction, you don't actually roll back the transaction, you tell the container to roll back the transaction. So when it comes to our two-phase committing, when the transaction manager says, hey, is everybody ready? Then it'll be like, hey, we need to roll back. So that's just pretty much putting your vote in early for that. All right, so just quickly looking at, I want to show some code quickly around container managed transactions. Let's go into presentation mode. So this is a stateless bean. So you can see, like I said, at the top of your bean, at the top of your bean, we go mark of annotation, transaction management, and tell what type it is. So the default type is container. So if you're not going to do anything else, container is what it's going to be. And the default attribute that's going to be, then I can maybe just put this in here. Transaction attribute is going to be the required attribute. So if we didn't put anything on top of this, this will be the default container and required. Then if any method in there isn't marked with your transaction attribute, we'll use whatever the class is using. So in this case, it will be required. And you can also go and override that transaction attribute on different methods. So we can see we've got a mandatory. Mandatory means that whenever a client calls a specific method on this bean, it's going to have an existing transaction already running. If it comes in, there's no transaction, it's going to throw an EJB transaction required exception, if memory serves. And then the bottom one here, the do more work one, is marked with a not supported. So if a client calls this, the container will actually suspend any transaction if there is one busy at the moment before coming into this method, complete it. Once it goes out, resume with the transaction that was there before. So you definitely need to understand and know these types of things. We're not going to do. There's another thing as well around synchronization. I don't think they'll call it. They might not ask questions about it, but just be aware of it. And if you go and watch the YouTube video from the transaction section, I explain. Okay. So the other one is the bean managed transactions. Like I say, you have to go and mark this as bean managed. This should be not your default go-to when it comes to transactionality in beans. When you container managed type components, because it does make the code more complex because you need to keep track of where you're doing what with these transactions. Because if a container managed transaction is running and it calls into a bean managed transaction, that container managed transaction gets suspended and the bean managed one goes off on its own. So just be aware of that. And if you are, and of course you can't mix it, you can't have a bean that's using container managed and bean managed transactions at the same time. It's one or the other. You can't have both. You can't have your cake and eat it when it comes to this. So the main thing is with a bean, you're actually going to programmatically go and set this, and we've sort of seen this looking at the entity transactions. So from entity manager, if you did a get transaction call there, you'll actually get your entity transaction, and that's just another interface into your JTA transaction. So a user transaction, if you're just looking at beans without using JPA, it's going to be exactly the same thing. It's just a hook or interface into your JTA transaction that's currently running on your container. So once again, that gets injected for an EJB context, and there's a lot of these sort of methods which are the same as we had with the entity transactions. Our begin, our commit, our rollback. I don't think it's got a set transaction timer. That you set in your JPA hints. And then with the status, the bean transaction can have a different status, state time. I don't know if it's like a cactus or cat time, but you'll have it can be active, marked for rollback, prepared, and that type of stuff. So generally where you use something like this is if you have some other run, if you're going to enter a sort of long running transaction or heavy processing or something's going to take a while and you don't necessarily want to enter that if another bean along the way has actually set the transaction to roll back. So you might get the status like, well, this thing has been marked for rollback, we're not going to continue, or it's already committed, I need to start a new transaction, or anything like that. So looking at a quick code, little demo of this. So if we're going to look at our bean transactions here. So the main thing is we're going to use a EJB context to inject a user transaction here. So if you were doing this with the JPA, you'd actually get it from your entity manager. Instead of injecting a transaction, actually we're injecting an entity manager, and from entity manager we'll get our transaction. But if you're not doing that straight, you'll just inject our resource like so. So you can go and get the status. And like with the transactions, we've got an entity transaction, you need to begin it, do whatever you need to do, and then you can either commit or roll back. So there's a few exceptions at the bottom here. And you've got this heuristic rollback and rollback in heuristic mixed exception. And these heuristic exceptions is what will happen on the two-phase commit if something goes wrong there. So either somebody says, listen, we're not committing because I've got a problem on my side. So one of the resource managers may say, no, we're not committing. Or in the process of committing, something actually goes wrong. It'll throw these transactions. I can't remember which one is which one though. But you can read that up. We're going to look at the YouTube video. But just be aware of it. I don't think you're going to need to know this for the exam. Then just getting back to actual entity managers, and we've seen these before. Saw them last week as well. We've got a transaction scope and container managers can be transaction scope or extended, and application managed entity managers, which you use in our EC environment. And you can also use them to do resource local transactions. So you can just go through those again. So the main thing is that just need to keep in mind is that our transaction scope or extended persistence, or even application managed uses the JTA, where our resource local transactions don't. So if you're doing anything, it's going to be a resource local type transaction, which doesn't have anything to do with JTA, then nothing is. Then all those JTA stuff from bean stuff, that's going to work. So I'm not really going to go through all of this again. Just a reminder on the entity manager stuff here. So like I said, so if we, let's get the right one here. So using our persistent context, we inject our entity manager like before, and then we can use it like that. If we're doing an extended one, we inject it as well, except that we set up persistent context to extend it. And this is only on stateful beans, so that's also an important thing. So if you see any extended and it's not on a stateful bean, that's probably not the right answer. And this going back, so remember, the reason we want to do extended is something like a container managed. The JTA, your container, is actually going to start or continue with a transaction when it enters your method, and then when it exits your method, it'll actually commit or roll back depending on what you did in there. So if you don't want that to happen, we use an extended persistent context for that. And you can also have the application one, which means that we'll don't necessarily want the container to control too much of it, but we use our persistent unit to inject our entity manager factory there, and then from our manager factory, we're actually going to create an entity manager. And we use it like before. But then with entity manager, you can also join transactions, get your own transactions. And the main thing is that if you're using the application managed one, so whenever you're using JTA, there can only be only one active transaction. If you're using resource local, there can be as many transactions as you want. All right, so let's get to the actual new work for this week. All the previous stuff was sort of revision. All right, so before we get into locking, let's just see why we want to lock and where all that comes from. So the reason for doing is that we want to actually isolate our data. So whenever we're busy for a transaction, that's an asset transaction, we actually want to, if we're busy with a transaction, that's part of the asset, and this sort of comes to consistency, is that we want to know that if we're going to do something on that data, when we save it, we know it's going to be saved. If we're reading data, we don't want any problems there. And the type of problems you can get from this isolation, not getting it, is there's three main ones, one being a dirty read. It's not when you buy some other book, like 50 Shades of Grey or something. It's not that type of dirty read. It's read when you read a record, but when you read it again, the data is actually different. So it's inconsistent. So you read the employee record, and now the guy's got 10 days of leave. You read it again, and now he's got 12 days of leave. So that's a dirty read. A non-repeatable read is if we actually go and I'm actually talking. That's a non-repeatable. So dirty read is we're actually reading data that hasn't been committed by other transactions. So we take an employee record, his leave days goes up because some other service is busy updating it, but he hasn't committed it yet, but we can really see that. So that's a dirty read. Non-repeatable read is you read a row, you read it again, and it's different. And then a phantom read is where you go and read some records, you get 10, and then all of a sudden you're only getting 8 back. So that's a phantom read. And the way we get around these is through different isolation levels, different ways. And the more isolation we've got, the more locking is going to happen. So for that, we get read uncommitted. Read uncommitted pretty much can give you all three of these problems. And then you get read committed, which will pretty much just give you dirty reads. Is one of the problems you can get there. Repeatable reads will only give you phantom reads, and serializable will give you no problems. So none of these problems will happen. So normally the default is read committed. I know on Hibernate, I think there's this repeatable read. But generally this happens sort of at a database level. So when you actually go and create your connection, you can set up what type of isolation level you want and actually have your database take care of that. And that's what we generally refer to as implicit locking. So you're actually leaving it to your resource to take care of what it needs to happen there. And you generally set this on your connection. If you're using a JPA provider, you set that in your properties. I've never set it there. So applying these different locks, so you've got your read committed, and so on. But you've also got different strategies for applying that locking, and this is where you sort of get your optimistic and pessimistic locking. And there's different reasons for using one or the other. So optimistic locking you're going to use if you don't necessarily want to go and lock every single record you read as well as that you're writing to. And optimistic locking actually says, listen, we're not expecting the data we're working on to change while we're looking at it or working with it. And we'll actually just go and check it if something has changed before we commit. So what you're doing there is if something did change or the record just did change and you pick that up and you commit, you're actually going to have more processing at commit time if something changed, but not so much while you're working with it. So you're sort of saying, okay, well, if we're going to have extra processing, let's take a chance that it's not going to happen that often, and if it happens, we'll take the hit. Pessimistic locking is the opposite of that. Pessimistic locking is you're pretty much sure the state is going to change while you're busy with it, and you don't want that to happen. So that's going to happen often. It means you're always going to have to sort of take care of that problem at the end. So pessimistic locking, you're actually saying, well, it is going to change, and you actually lock down the data right at the front. So you don't, not before you commit it, not at the end, actually right from the start. So the difference is pessimistic locking is you're locking it down from the start. Optimistic locking, you're not locking it, you're actually just checking at the end. And we'll look at the way optimistic locking does that in the next slide. So it's all about the amount of contention you're going to have on this data. So you're going to have a lot of contention, then you can use pessimistic. If you're not going to have a lot, you can use optimistic. And pessimistic locking should really be your last resort. If you're going to have any type of enterprise application which is going to have a lot of usage, a lot of users and concurrency and so on that, pessimistic locking is really going to slow it down. Because generally the databases, and every database has its own way of locking, but a lot of times they'll either lock down the table, like DB2, or they might lock down a page, like SQL Server, which will mean they'll lock down that record and 2 or 3 records above and below it as well, which means anything that's going to want to read that is not going to be able to read it. So that's nice. Optimistic should be your last resort to look at it. And of course, JPA supports both of these. And the default JPA isolation level is recommitted. And there's one thing that you need to know is that the JPA does locking at the database object level. So you're pretty much locking a record. So if you're locking your entity, you're locking that specific entity. If you're locking down an entire table, locking down an entire table. So at the database object level, it's not a database. You're not locking down. So you're not locking down the entire table or the entire database. You're actually locking down the objects or the rows in there. Have I got 2? Okay, that's wrong. Need one slide. All right, so first let's look at optimistic locking. So optimistic locking happens at commit time. That's sort of one thing to remember. We can look at the different lock types. And just remember that anything that's got anything to do with optimistic locking happens at commit time, not anywhere else at commit time. So what's going to happen is if you're going to get to commit time and something has changed, then you're going to get an optimistic lock exception is going to be thrown. So you need to handle that. And there's a few ways of doing that. You can either retry the transaction, or you can go back to the user and say, listen, user, this sort of broke. You need to redo it again. Or you can just log it and just ignore it. You know, I mean, make it somebody else's problem 10 years from now. But the thing is when that exception gets thrown, you have to handle it. And that's sort of where optimistic locking comes in, is that you're not expecting that to happen a lot. You're not going to have a lot of records that are going to be throwing optimistic locks. So if you start getting that, then you probably need to start looking at pessimistic locking. So the main way that pretty much everything does optimistic locking is through versioning. So when you read that record, or when you try and update it, you're going to get that record from the database, and it's going to have a version on it. And that can be a number or a timestamp or a hash or something that's going to sort of a way for the database to pick up, or your provider to pick up, listen, this has changed. So when it comes to commit time, it's going to go and check and see, listen here, I've got version 1. Is the version in the database version 1? So if it isn't version 1, or the hash is different, it means it's changed, so we're going to get an optimistic lock exception that's going to be thrown. So some providers just do this automatically. Other ones, you can actually go and add a field specifically that you're going to persist as well. And you mark this field with your version attribute. It's probably XML for this as well. I didn't look. And when you go and mark something with an @version attribute, then your provider is actually just going to automatically update that version. You don't have to go and do it any time by yourself. And you probably don't want to go and update this manually anyway. One thing to be aware of, though, is that that version sort of gets updated in memory when you get it, and in your persistent context, whatever says it's going to be in memory. If it's a new one, it's also going to get a new version. But if a rollback happens, remember, if you recall back to a few weeks ago, if a rollback happens, those entities are going to be detached. So they're still going to have the same data, because there's no way for the provider or to go and figure out, listening, how do I roll back? What was the data before? So it actually just detaches those entities. So if that entity gets detached, you just go and merge it back in again. You might stuff around with the version numbers and all that type of stuff. So you can either just restart from scratch, or go and set that version number to a null, or just go and copy the data across to your new entity before putting them in. In general, with optimistic locking, having a version number on there is fine and it's good to go. But sometimes you might want to be more explicit about it. Okay. Question? So you can actually go and set more implicit locking options, and call it advanced optimistic locking. And you can either do this on your entity manager lock method. So that's actually where you say entity manager.lock, and you say I want to lock down to a specific entity and what type of locking you want to do on it. Then you call the refresh method, the find, or your set lock mode on your query interface. And for that, you've got, well, there's actually there's two options for optimistic. You've got locked up optimistic or read. So that pretty much says that it's sort of the default, and says specifically go and check this when I committed that the version hasn't changed. An optimistic force increment is the same as optimistic, except that with an optimistic lock, you're only going to update that version number if you actually update the entity. With optimistic force increment, you're updating that version number when you read it as well. So it's, but it only checks it still when you're at commit time. So optimistic force increment is also the old lock mode type .write. And for the certification, you'll need to know all four of them. So optimistic is the same as read, and optimistic force increment is the same as write. I'm not sure why they changed it. Couldn't really find why. Because they didn't change pessimistic one at all. So you're looking at pessimistic locking. Like I said, as opposed to the optimistic one, this locks it immediately. So if you say lock, it's going to be locked down. And you also need to be careful with that. So the fact that it's going to be locked down immediately, it's not going to help you to actually only go and lock it down before you update it, because it might have changed in the meantime. And that's specifically what you're trying to avoid. So you're either going to have to lock it down right in the beginning, read it. So it also depends on how much processing is going to happen between reading that object the first time and updating the object. So you might have a scenario where you want to update students' average grade or their grade or something. So you're going to read that student's details, maybe calculate the average, and then write the average back. It's a bit of a stupid use case, but you might do something like that. So, but from the time you read it to the time you update it, if that's going to be a long time, you might not want to lock it down right in the beginning, and then just lock it down right at the end and just quickly redo whatever you need to do with it again. If it is going to be short running, then lock it, do what you need to do, and commit it. If for whatever reason the provider can't get a lock on that object, or something else has got a lock on it as well, you can get a lock timeout exception. If there's something really bad that's happening, I don't know how bad, they say it's severe, I don't know, maybe the database has gone down, or the building's on fire, you'll get a pessimistic lock exception. And I think the pessimistic lock exception actually rolls back the transaction. Yeah, I think it rolls back the transaction. With any of these exceptions, and just mentioning that now, when you're studying for the certification, make sure to go and check and make sure which exceptions actually roll back transactions. Because that also makes a difference. Because if a transaction is rolled back and you try and persist something, it's probably not going to work. Once again, your pessimistic ones, you can also set on your lock, refresh, and find methods on Entity Manager and your set lock mode on your query interface. And with the pessimistic one, you've actually got three different options. You've got a write and a read, and you've also got a pessimistic force increment. So starting with the pessimistic force increment, that pretty much is the same as our optimistic force increment, except that it does it right in the beginning. Like I said, the difference between optimistic and pessimistic is optimistic does it at commit time, pessimistic does it immediately. So I'll lock my type there. If it's pessimistic force increment, it'll actually update your version number right at the beginning, as soon as you access that, get that object or that entity the first time. Then your read and write ones pretty much is different types of locks. So both will lock down your entity right at the beginning, as soon as you refresh it or lock it or find it or do a query against it. And the main difference between it is if you've got a pessimistic read lock, any other entity manager or persistent contacts or transactions also got a pessimistic read lock will be able to read the same data, but nothing else will be able to change it. So even if you've got a pessimistic write lock, it won't be able to go in there and actually change it. If it's just normal optimistic transaction or isolation, it's not going to be able to update it. So pessimistic read will only allow another pessimistic read to read that data or access it. Otherwise, nothing else will be able to get in there. The pessimistic write, though, is pretty much locks it down completely. So that's like if we're looking at the isolation levels, that's sort of serializable. It means that nothing can read it, nothing else can write to it. Doesn't matter what type of lock mode you're in. Pessimistic write pretty much locks it down completely. So that sort of should be your last option. That's the highest level of isolation you can get. Then there's also, when you're locking down an entity, that entity might have relationships, and you can sort of say if you want to lock that down or not. And with that, you've got some properties you can set. So it's the Java persistence lock scope. That can be extended. I think the other one is normal. So if extended is if you actually want to extend that pessimistic lock to a unidirectional relationship. And then you can also set your persistence lock timeout. So most providers do implement this, but it's also, once again, it's what you said on your hints. If you remember when we did the entity managers and so on, you can see hints on those. So it's just a hint, might be followed, might not be followed. And here's just a little summary of those different types of lock modes. So none is also there. And you just, none pre and post means it's implicit. So you're kind of telling the provider, listen, whatever is there, use it. Optimistic and read it's the same. Optimistic force increment and write is the same. And then we've got our pessimistic read, write, and pessimistic force increment. All right, so quickly look at a little demo. There's no questions. Good. View. All right, so I've got the same entities we've had for the last 2 weeks with the queries and the criteria builder and that. And then I've also got a actual bean here, the employee service bean. So the one is to list employees and the other function is actually going to increase them. And at this stage, there's no locking or anything on this. Just looking at our transaction management, I've just put in there that it's container. So that'll be the default one. And also the transaction attribute that will be default on here is the required transaction attribute. And I've also just got a controller, so a little REST service, which I'm going to call into. So one is to list it, one is to increase it, and one is to, well, this is a test one. So first off, the one way you can lock this, I said the one method was using our entity manager and actually using the lock method on there. You can pass it the entity we want to lock, so in this case it will be this employee, say next. And we can say what lock mode we want to do. So for this, we've got our different ones there, forward increment, optimistic, pessimistic, non-pessimistic, and we've also got the old ones to read and write to be backwards compatible. So it makes it optimistic. It means that at commit time, so when it gets to the end of this, it will actually go and check, listen, is everything cool with this thing? Did it change? Did it change? Then it'll throw an exception. One thing also with exceptions in EJBs, I think that same video has some stuff on the exceptions. Just be aware of where these things happen, and you maybe don't want the container to pick it up because then it might be gobbled up. So, and the other place we can also do is on our create query objects. You can go and set the lock modes on them. And like with a criteria where you can actually chain these together. You can set our lock mode there. Once again, it'll be the same ones. It's optimistic. It doesn't really matter. Let's comment it out. You can be optimistic there. And set this in here as well. So on a read one, we've got an optimistic one, and on our write one, we've also got. So on a read one, we'll just go and check and say, listen here, did anything change on this? At commit time, so if nothing changed, it'll be cool. So in our increase one, but actually when we commit it at the end, it'll go and see, listen here, has this changed at all? If it hasn't, then it'll commit it. Also, just looking at our employee one, so I've added here, I've added a add version little attribute, and I've added a version little attribute there. And for this, you can call this whatever you want. It just needs to have the right attribute. And like I said, the type here can be an int, a long, it can also be a SQL timestamp, and something else. I'm leaving one out that you can add there. Let's go and run this. Actually, let's package it first. And using Tommy again. Let me run. All right, so got off different methods there. We're running the right one, yeah. No, I'm in the wrong. Yeah, that doesn't help. Running the wrong instance here. We'll get to the right one. Say that looked wrong. We need to be on this one. There we go. Okay, so let's just package this one. And to SQL here. We can see if I go and execute this method here, we've got our employees here, and at the moment they're all version 5. So nothing has changed here. That's what isn't. We're going to see what happens when we actually do something there. So the first thing we're going to do is just going to call the list employees service. We're just going to use Postman for that. So calling our list function there. As you can see, it brings back our list of employees. We're going back to our database, and we actually go and execute this query again. We can see the version numbers are the same. Nothing has changed yet. What you can also go and do is you're going to go and increase these salaries of these guys. So let's go and say, it's Christmas time, everybody gets an increase. If we then go and see what happened to that version number, we can see that's been updated. This is updated now. Main thing being pessimistic, optimistic, it only did that at commit time. It actually checked for a version changed, if a version has changed. Okay, so the other thing we can also do is we can have a different optimistic type here, and we can say it should be optimistic force increment. Like I said, then it updates it even if we're not updating the actual entity. It'll still go and update the version number. We package this. So you should see now, so if I ask for a list of employees again, it'll update the version number. So go to our list. Employees, and run this query again, so that should go from 6 to 7 now. So that's updated. So that's the difference between the read and the write optimistic one. Well, I'm not going to, if you want to see a pessimistic demo, you go look at the JPA2 book code and so on. I didn't get around to setting one up for that. All right, so any questions? So for this locking, and this locking is sort of one of those things, if you do get down to that level, you're probably going to add some complexity to your code. So don't just go and start using it all over the place. It's something you probably want to, it's one of the tools you can use, and then if it's required, you can put it in there, but there's probably other ways around it sometimes. So this should sort of be one of your last resorts, and a pessimistic lock is really one of your last resorts. Like I said, that's going to really slow down the system. If you're ever going to, places you might use this locking as well, if you don't necessarily, or you can't change the type of entity manager you're using, if you've got something like an audit log, you might set the isolation level differently, stuff like that. But anyway, this sort of locking is sort of one of those things. As soon as you start going down that path, then you're going to add complexity, a lot more complexity to your code. the same thing as using bean managed transactions or application managed entity managers. All right, so next week, this is the last week of doing this. So this weekend, quiz again, 10 questions. Next week's reading material there's quite a bit there, but some of it is around the embedded objects where you can override attributes and some compound primary keys. Anything that's new is the lifecycle callbacks. And then I've also got the links for the EJB demos. So if you want to go and get any of that EJB demos, it's on my GitHub account, EJB certification project. And then the EJB transaction class from earlier in the year, there's a link for that on YouTube. You can go and watch. And then the other things I just want to mention is that I've got Josie Jug again on Monday. The last, well, not the last one for the year, but the last one that is actually they're going to be presenting on. And it's about the ALK stack, so it's Elastic, Logstash, and Kibana, and just how the guys at Standard Bank on the mobile team actually use that to improve their logging and finding issues and so on. So it's at Standard Bank in Rosebank. It sounds like it's going to be awesome. Nice catering there. So definitely try and pitch up. You can see we already had 166 people going, and there's only 34 spots available. So get the tickets while they're hot. We'll find out about parking. I think we're still waiting to hear about parking there. There's Rosebank. They're right there, so you might have to park in Rosebank. I don't know if there's going to be parking at Standard Bank itself. But let's go on to Meetup, and we'll update the Meetup stuff on here when we know. Then the last Josie Meetup for the year, that'll be the week after, so in 2 weeks' time. It will be like the previous years, where we actually, instead of having a speaker, we're actually going to do some coding, and we're going to try and write some AI bots. So those of you who know about Intellect's the Intellect challenge that they have every year, the 100,000 Rand challenge, we're going to sort of do that. So we're going to write about, I think this year that at the tanks this year, was the tanks last year? I don't remember now. But so you're going to team up for that. That's usually fun. We did RoboCode last year. It's lots of fun. So it's kind of cool. You go, write some code, play around. Might be a prize, might not. I'm not sure. And then just moving away from Josie Jug, we've also got the Duck, the developer user group. So it's not necessarily the .NET version of the Josie Jug. It's actually supposed to be more of a polyglot user group. Although they are at Microsoft and people still associate them with the Microsoft technology stack. But they're doing the Geek of 2015. So if you haven't been to one of these before, it's quite a lot of fun. And this is the 8th of December. So it's at the Microsoft campus in Bryanston. It's like a pub-style quiz. There's lots of prizes and really cool prizes. So they generally have different categories. Last year they had like superheroes and different code. And you have to identify what language the code was written in and stuff like that. So for each category there'll be winners. There's like spot prize winners. It's really a lot of fun. So if you can join that as well. So this is one of the first sort of combinations where the Duck and the Jug sort of are promoting these things together. There's also a conference maybe next year which the Duck and the Jug are going to be organizing. So look out for that. So I say so meetups for the next 2 weeks. Elastic, the ALK stack at Standard Bank next week. Week after that at Intellect, they're going to build some AI bots, and then the Geek of 2015 at the Doug in 2 weeks' time as well. Those who haven't gone to a meetup before, this is like really some cool ones to go to, and it's sort of nice to sort of get into that type of environment where you meet up with your peers, see some really cool presentations, learn about some really nice new tech, and it's sort of getting into that community and sort of seeing what it's all about. It sort of makes you feel like it sort of broadens your world. You sort of see a bit more, talk to other people. You're not just sort of seeing how Java works in your team or in your project or in your company. You actually see how people do things in other companies as well. And that's never a bad thing. So our attendance keyword, so any questions? So our attendance keyword for the week is lock. Okay. So lock is the keyword for the week. People remember to write the quiz this weekend. I'll send out a reminder again on Friday. Maybe I don't think it will be a Doge one again. Might be a different one. But anyway, enjoy the rest of the week. Cheers, bye.